Hello everybody, today we'll talk about playback filters. So audio filters are filters that amplify or attenuate a particular frequency or a band of frequencies based on the user choice. Now playback filters are the same, but they provide the ability to listen to the audio filters. So it's very useful because as soon as you apply the filters, you can actually listen to them, to check whether it's working or not. And there are several types of filters, such as low pass, pass, band stop, notch, and many more advanced versions. However, we'll only discuss a few in this video. So first, let's say we have a problem. You can listen to the noise first. So after listening to the noise, we can conclude that we can hear a pure tone and some broadband background noise. Now, in order to understand what is the frequency composition of this signal, we need to plot a spectrograph. So once we plot a spectrograph, we can see this in the screen that there is a line spectra, which is nothing but a pure tone, and there is some broadband noise. Now, the x-axis in this spectrograph represents the frequency axis, so the tone is approximately around 1 kilohertz, and the broadband noise is above 1 kilohertz. So it's like a high frequency broadband noise. So now, we need to get rid of that. So you need to know what the goal is. If you want, you can get rid of the tone or you can get rid of the high frequency noise. But in this case, I'm going to demonstrate how to get rid of the high frequency noise. So in order to do that, we need to apply something called as a low pass filter. Now, a low pass filter is a filter that passes or accepts frequencies within the cutoff and rejects all the frequencies above the cutoff. So in this case, it makes sense to use a low pass because we want to accept the tone and reject the high frequency noise. So we're going to design our filter such that we accept the tone and get rid of the high frequency noise. So this is a low pass filter. I've chosen a cutoff frequency of 1100 hertz. So I accept everything up to 1000. So I get my pure tone and I reject everything above 1100. So I apply the filter. This is how it looks like. So I have rejected the high frequency noise completely and I've only accepted the pure tone. You can listen to them. So as you listened, you can no longer hear the high frequency noise because it has been filtered out. So this is one use case of a low pass filter. Next, we will look at a use case for a high pass filter. Now, again, let's listen to the audio file. So if you listen carefully, it's just me playing the whistle, but then I've used a generic microphone to record my own whistle. So there is this wind noise blowing out of my mouth, which is reflected here in the spectrograph as a low frequency noise. And the tones are my whistle, the first harmonic and multiple harmonics. So in this case, the goal is to get rid of the low frequency noise and to only keep the whistle. So we need a filter that accepts something in the higher frequencies and get rid of the lower frequencies. So this is a use case for a high pass filter where we accept the higher frequencies above the threshold and reject frequencies below the threshold. So I studied the spectrograph and I realized that, the first harmonic is around 1300 hertz. So I choose like 1250 as a cutoff. So I accept every frequency above 1250 and reject everything below that. So by doing that, I accept only the whistle and reject the low frequency noise, and I apply the filter, and this is how the spectrum looks like. So the low frequency noise is completely removed and we're only left with the whistle, the fundamental, and its harmonics. You can listen to them. So the next case is a tonal noise. In this case, there is a background noise and a tone. You can listen to the tone. So as you listen, you can hear a broadband noise and a tone. Now you plot the spectrogram, you can see that there is a widespread broadband noise, covering the entire audio spectrum, and there is a tone standing out at 1000 hertz. And in this case, the goal is to get rid of the tone, but keep the background noise. And this is a use case for a notch filter. A notch filter typically removes one particular line frequency. So we remove the 1 kilohertz and then we're still left with the broadband noise. You can hear that. So as you heard, we can no longer hear the tone, but only the broadband noise. This is a use case of a notch filter. So there are many more filters such as band stop, band pass, harmonics. However, I couldn't demonstrate because I don't have, those are not available in the software. But to conclude, always, if you want to understand how do you have to approach the filtering process, study the spectrograph. It'll give you valuable information of what frequencies are present, and then you can make a judgment as to what frequencies you need to get rid of or what frequencies you need to keep. And after applying, always listen to them so you get an audio feedback as to whether the filters that you have chosen are working or not. And multiple times it's necessary to use lots of filters in combination. The examples that we have discussed here are pretty simple, but these are the basic blocks. You have to use like multiple low pass and high pass in conjunction with each other. So that's how you approach this problem. Thank you for watching this video. I hope you enjoyed it. Have a great day.